One thing I can see that some of you have not done anything with with the module exam. You see, you have the sum of the module exam here: 1 to 3, 4 to 7, now 8 to 10.
Yeah, I got it now.
Yeah, remember you have to do it also. It account for 15%. So take your time to finish it.
Yeah.
Okay, so let me go with today. We continue with where is this? Okay, let me continue with subnetting here. So that want to review a little bit about that. We know something about the sorry, you know something about. Let me share the screen here. We know something about the you know something about what is it, magic number, right? You have the magic number. Okay, anyone have idea what is the magic number? What is the magic number? What is the magic number? Come on.
So is it the number of bits you're borrowing from the host portion of the address to create subnets and moving them into the network portion to create subnets?
No, that is a number of subnet. I'm asking about the magic number. What is the magic number?
Oh, is it 2 to the n minus 2? Where n is the number of bits borrowed and the result is the number of usable addresses?
So you have some definition here, right? So first thing you have to understand what's the magic number. The magic number is the value of the number one in. Sorry, the magic number is the value of the last number one in the subnet mask. Right? So if you remember about the subnet mask here.
Yes. I'm sorry, I forgot that.
Okay, it's okay. For the subnet mask again, it has the 32 bit of the subnet mask, right? And again, it's break it down into the network portion and the host portion here. And remember, in the subnet mask, the network portion you have every bit number one, and for the host portion you have every bit number 0 here, right? So the magic number is the value of the last number one in the subnet mask here. And you have to remember everything about the table here, right? In the octet, in one octet, you have the 8 bit. So we have the bit number 0, number 1, number 2, number 3, number 4, number 5, number 6, number 7. In the one octet, you have you have the 8 bits in one octet, everything from the 0 to 7 here, right? And for each of the octet here, you have specific value for that. You have 2 raised to 0 for this one. You have 2 raised to 1. You have 2 raised to 2. You have 2 raised to 3 for this one. Raised to 4. 2 raised to 5. 2 raised to 6. And 2 raised to 7 for this one, right? And 2 raised to 0, you have 1 here. You have double it. You have 2. You have 4. You have 8. You have 16. You have 32. You have 64. And you have 138 here, right? That's everything you have to remember about the place position here. So remember one thing: the magic number is always the last value. It's always the value of the last number one in the subnet mask here. So if you think about, you have the subnet mask here 255.255.255.224. So can you tell me what is the magic number for this one? What is the magic number for this one? If you have 255.255.255.224, it's a subnet mask. So what is the magic number here? Again, I had to remind you that you have to totally understand the the definition of the magic number, the network address, the broadcast address, usable address here, because you will see it in the practice set and skill set. And a lot of you find that everything with the networking here, IP address here is the most challenging thing in the exam. So I hope you to pay attention on the class here and to figure out how to working with the magic number, how to working with the network address here. So now my question again, if you have the subnet mark 255.255.255.224, what is the magic number here?
32.
32, right? Very good. So you can break it down. You see, if you have 255, that means you have edge number 1, 255 here, you have edge number 1, 255 here, you have edge number 1 here, right? So now 224, you have to break it down. This one, 128 here, right? This one, 64 here. You add them up together, and now you already have the 192. And you need one more. You have one more here, the 32. You add them up, you have the 222 here, right? So after that, you see, you have file number 0 here. All right. See, Z is the last number 1, and Z is the magic number. And the magic number for this value here, you look it up, you know that this one is the 32 here. Okay, that is the thing you figure out what is the magic number. The same when you have the subnet mark in the slot notation. So you have the slot 19 here. So what is the magic number for this one? What is the magic number for this one? If you have the subnet marked is a slot 19 here, that means you have 19-bit number 1 and you have the 13-bit number 0. So what is the magic number for this one?
$32.
32 again. Okay. So now see, you have 19, right? So we have 8-bit number 1. You have 8-bit number 1 or 16, right? So you have the 17, you have 18, you have 19, and of course you have the 5-bit number 0 here. And the last one, you have the 8-bit number 0 here, right? So we see again, if you look on this one again, this one 128, this 164, and this one 32. So you know that this one is magic number, also 32 here. But if you look on this one and you look on this one, the magic number for this one is 32, but it is the 4th octet here. It's the 4th octet. But for this one, the magic number here is in the 3rd octet here. Right? So remember one thing: when you figure out the magic number, you also have to know what octet it is. What octet it is, right? So now come back to this one. In the homework, you have the sum of the. You have something you have to do with the. You have to figure out what is the magic, what is the network address, and what is the broadcast address here. Let me save it here. Okay. One thing you know that the network address only increased by the step of the magic number. You have to remember that the network address only increased by the step of the magic number. That means when you have the network address, you divide by magic number, you have no remaining here. You have no remaining. Okay, so now think about this one. You take this one as example here. You have host IP address. You have the subnet mark here. Now you have to new subnet mark. All right. So this one is original one. So if you look on the subnet mark for this one, what do you think? How many bits in the network portion and how many bits in the host portion for this one here? For this one, you have 255.255.0. What do you think? How many bits in the network portion and how many bits in the host portion?
There's 24 in the network and 8 in the host portion.
Yeah, right. Because you see, when you convert it to number 1, you see, you have 255. That means you have 8-bit number 1 here. 255, you have 8-bit number 1 here. And 255, you have 8-bit number 1 here. Right? And the last one, you have 8-bit number 0. Every bit number 1 is the network portion. And every bit in the number 0, you have the host portion. So for this one, you have 24-bit number 1, and you have 8-bit number 0 here. Okay. Now we see for the new one here, what do you think? How many bits in the network portion and how many bits in the host portion? If you have 255, 255, 255, 240 here, what do you think? How many bits?
Okay.
Yes.
28 in the network portion,
Yes, right. Because
and then 4 in the host.
yeah, so we see again 255, 255, 255 here, 34, right? So 240 you convert it, this one 128, this one 64, you add them up together, you only have 192, right? And this one you have 224, and this one you have 240, and of course you have 4 more 0 bit here. Okay, so we see for this one 6, 16, 24, 25, 26, 27, 28 here. So for this one you have 28 bit in the network portion, and you will have a 4 bit in the host portion here. All right. So now we look at this one. This one is the original one. At the beginning, you have 8 bit in the host portion. Now you have only 4 bit in the host portion. That means you already borrow 8 bit. Sorry, you already borrow 4 bit. You already 4 bit from the host portion. You bring it to the network portion. You borrow 4. That's why you have the 28 for this one. You borrow 4. You minus 4 for this one. You only have 4 bit here. All right. So if you look on this one, you know that at the beginning you have slot 24. All right. Now you have slot, sorry, at the beginning you have a slot 24. Now you have slot 28. That means you borrow 4 bit. Okay. So when you borrow 4 bit here, what do you think? How many subnet bit you have? You borrow 4 bits. That means they are the subnet bit here. All right. And if you borrow 4 bit here, how many subnet it created here? What do you think? If you borrow 4 bit, how many subnet you have? If you borrow 4 bit, how many subnet you have?
$16.
Yeah, 16. Right? Because again, you always have to remember 2 formula here. The first one is the number of subnet. If you borrow n bit, in total you have 2 raised to power of n subnet here. All right, so for this one, you borrow 4 bit. In total, you have 2 raised to 4. You have 16 subnet here. All right. So number of host bit per subnet. You see, for this one, you have slot 28. That means you only have 4 bit left in the subnet, right? So this one is a 4 bit here. Now, if you have 4 bit in the host portion, how many hosts per subnet you have? The second formula here. How many hosts per subnet you have? The second formula here.
So we have 14
That's
hosts per subnet.
So the second formula is that if you have 8 bits in the host portion, in total you have 2 raised to power of 8 minus 2. You have to minus 1 from the network address, and you have to minus 1 from broadcast here. That's why you have to minus 2. So for this one, you have 4 bits in the subnet. So in total you have 2 raised to power of 4 minus 2. This one 16 minus 2. You have this 14 here, right? So now in the original network, you are able to break it down into 16 subnets, and each of them support for 14 usable address here. Now, the question here, what is the network address? What is the network address? Of course, you know that you're able to figure out the network address by the ANDing logic. Right? In the case of ANDing logic, you break it down everything into 0 and 1, and you ANDing everything together, ANDing every single bit together here. Or you can working with the magic number. You can working with the magic number. Now, come back to this again. You know that this one is a slot 28. This is the magic number. Right? This is magic number here. This one 128. This one 64. This one 16. And this one 32. So for this one, you know the magic number here is 32. And it is in the 4th octet here. 4th octet. Right? So we have to focus on this one. You have to focus on the 1st octet. Sorry, on the 4th octet, it is 70. And the network address is always divisible by the magic number. Right? So from the 70 here, you have to find out which is number close to the 70. And when you divide by 32, you have no remaining. So what do you think? Which number is close to 70? And when you divide by 32, you have no remaining here. What is it?
64.
Yes, that's all. You can working on the calculator here. You can work on the calculator. You have, say, you have the 70. You divide by 32. You have something here, right? Remember that the network address is the one who divisible by the magic number. That means you have no remaining. So you take the number 2 here. That is you take number 2. You time it back. You time it back to the magic number. You have the 64 here, right? So for this one, no, what is it? Where am I? What? This one, right? So for this one, you know that this one keeps the same. 192 here. 168. Dot 200.64. It is a network address. 64 is a network address. So the first hop in the this one, the first usable address is the one come right after the network address. That's why you have 192 here, 168.200.64 here. Sorry, 65 here. That is the first usable address in the network here. Now the question. What is the broadcast address for this one? What do you think? What is the broadcast address? What is the broadcast address? The broadcast
96 or 95.
No, not 95. Okay, so we see this one is the network address, right? For the subnet. So what do you think? What is the network address for the next one? What is the network address for the next subnet here? Remember, the network address only increased by the magic number. Huh? Oh, sorry, my mistake here. I think I make mistake here. This one. Yeah, sorry, my mistake. This one is magic number 16 here. I make mistake here. Sorry for that. But anyway, it's the same. The network address is the same because you see this one is 128, this one 64, this one 32, and this one 16 here. Right? So sorry. The magic number for this one is 16. And you have to find out which one is close to the 17. And when you divide by the 16, you have no remaining. So you do the same. You have 70. Now you divide by magic number 16. You have 4 something here, right? Forget about the 4. Forget about something after 4. You take the number 4. You time it back to magic number. You have 64 here, right? So that's where you figure it out. Now, you know that the network address for this one is 64. And the magic number here is 16. Remember, the network address only increased by the step of the magic number. So if you think about, you have next subnet, the network address here, you add it up to the magic number, you will have the next one is 192.168.200.80 here. That is network address of the next subnet. Right? So the broadcast address for this subnet is the one come right before the next one. So that's why you have 192 here, 168.200.79. It is the broadcast address. You got it? Hello, you got it?
Yeah, I thought the magic number was 32.
Yeah.
That's why I was thinking it was 89 or whatever.
Yeah, that's my mistake. So what is the last usable address here? The last usable address is the one come right before the broadcast, right? So you have 192 here, 168.200 here, .78. So you see everything from the 65 to 78, they are usable address. That means you're able to give it to computer, you're able to give it to any device. 64 is the network address and 79 is the broadcast address. You cannot use it. It's reserved here. Okay, so make sure that you understand the problem here, because you expect that in the skill exam and in the practice exam, you have to do the same. I give you the same problem here. You have to find out what is the number of bits in subnet, how many subnet you have, how many bits in the subnet, and how many usable address in the subnet, and what is the network address, what is the broadcast address, what is first usable address, and what is the last usable address here. Okay, now you do the same with this one. Okay, now we do the same with second one here. Now look at the original subnet mask here. What do you think? How many bits in the network portion and how many bits in the whole portion you have for this one? The original one here. Original one here. What do you think?
There were 16 in the network and 16 in the host.
Yeah, right. So because 255 here to 8, 255 here to 8 bit number one. That's why for this one, you see, you break it down. You have the 16 bit in the network portion and you have the 16 bit in the hot portion. You have /16 here, right? You have /16 here. Now, if you look at the new subnet mask, you have 255, 255, 224 here. So what do you think? With the 224, how many bit in the network portion and how many bit in the hot portion? Of course, you can convert, you can use a calculator here, right? You can use a calculator here. You go with the program. You go to 224, you see? You want to convert it, you have the 110 here, 50 here, right? So for this one, when you look on this one 8 bit number one, right? This one's 8 bit number one, you already have the 16. And we go on this one, you have 17, you have 18, you have 19 here. So with the, with this one, you have the /19, right? Now we have /19, and you know that you have 19 bit in the network portion, 19 bit in network portion, and you have 13 bit in the hot portion here. Okay. Okay. So now we see. Look at the screen now. At the beginning, you have the 16 bit in the hot portion. Now you have the 13 bit in the hot portion. At the beginning, you have the 16 bit in the network portion. Now you have a 19 bit in the network portion. All right. So what do you think? How many bit you borrow here? How many bit you borrow from the hot portion? You bring it to the network portion. How many bit you borrow here?
We borrowed 3 bits.
Yeah, right. Now you see at the beginning you have the 16. Now you go to the 19. That means you borrow 3 bit. Okay, borrow 3 bit. Borrow 3 bit. How many subnet you have? The first formula here. How many subnet you have? If you borrow 3 bit, how many subnet you have?
8.
We have 8.
Yeah, 8, right? Raised to 2 to raise to power 3, you have 8 here. Now, how many bits in the hot portion you have? How many bits in the hot portion you have? 13 here, right? Because you have 19 bit in the network portion. That's why you have the 13 bit left in the hot portion, because total you have 32 bit here, right? So for this one, you have 13 bit here. All right. With 13 bit in hot portion, how many hosts you can have? You can use the calculator here. You can use the calculator. You have scientific here. You have 2. You raise to power of 13. You have the 8,192, and of course you have to minus 2 here. Right? That's why you have 1. You have 8,190 usable address here. All right. So we see you have 2 raised to power of 13. You minus 2. You have 8,190 here. All right. Okay. So now you have to find the network address in the subnet. Remember, if you want to find the network address in the subnet, you have to find out what is the magic number and in the which octet here. Right? So what do you think? What is the magic number here for this one? What is the magic number? What is the magic number here? Slash
32.
32, right? Yeah, because you see, you break it down to 224 here. That means you break it down, you have 1, you have 1, you have 1, and you have 8. Sorry, you have 5 bit number 0 here. And the subnet, the magic number is the last number 1. So for this one, 138. This one, 64. This one, 32, right? So you know the magic number here is 32. And it is in the third octet here. You know that it's in the third octet, in the third octet. So now you have to focus on the third octet here. Right. From this one, you have to find out which is the number close to the 99. And when you divide by the magic number, that means when you divide by 32, you have no remaining here. So which one is it? Which one is it? Which number close to 99? When you divide by the magic number 32, you have no remaining. What is it?
Be 3.
Sorry?
Be 3. Be the third sub or the third network.
Yeah, 3. But what you have to do next? You have to take the 3. You have to time it back to the magic number. You got it?
That'd be 96.
Yeah, right. Some of
Yeah,
you
the
make
first-
yeah. Some of you forgot the step here. So we have to remember that you take the number, you divide by magic number, you have number 3 something, right? Now, when you got the number 3, you have to time it back. You have to time it back to magic number. You got the 96. It is a number close to 99, and when you divide by 32, you have no remaining here, right? So for this one, you know that this one keeps the same. You have a 10 here. This one keeps the same. You have a 1 here. This one is 96 here. And this one, you change it to 0, right? Every bit in the hot portion of the network portion, it's 0. That's why you change it to 0 here. All right. So now, if you have the 10.101.96.0 is a network address. So what is the first host? What is the first usable here? What do you think? What is the first usable here?
Be 10.101.96.1.
That's right. So we have the 10.101.96.1. Now think about this one. What is the broadcast here? What is the broadcast? So in order to know what is the broadcast, you have to find out what is the network address of the next subnet here. What is the network address of the next subnet? This one is the network address, and the magic number here is 32, and in the third octet here. So we just add it up to the magic number in the third octet. Right? So we have 96. You plus to 32, you have 128 here. Right? So the network address of next one is 10.101.128.0 here. Okay. The broadcast address is the one come right before this one. So what do you think? What is the one come right before this one?
Be 10.101.127.255.
Yeah, very good question. Sorry, answer here. So we have 10.101.127. Right? You have the less than this one, and of course you have 255 here. Okay, and the last usable address is the one come right before the broadcast here. So what is it? Come right before the broadcast here. So what is it?
10.101.127.254.
Yes, that's all, right? So that's the way you're working with the subnet mask. That's the way you understand what is a subnet bit, what is how many bit it creates, how many bit in the hot portion, everything was this one. All right. So remember, in order to do that, you have to remember 3 things here. The first one, what is the magic number? Magic number is a value of the last number 1 in the subnet mask. Right? That's the first one. The second one, if you borrow n bit from the hot portion to the network portion, in total, you have the 2 raised to power of n subnet mask here. That is the second one. The third one is that if you have h bit in the hot portion, in total, you have 2 raised to power of h minus 2 here. Usable right here. That's all. That is 3 things you have to remember when working with the subnet here. Now, everything clear now? Let me know. If you're not, let me know here, because again, I have to remind you again. You are expected to totally master on this one in order to working with the skill exam and practice exam here. If not, it's very, very challenging for you to working with this one. So any question from this one, let me know. Any question?
I don't think I have any at the moment.
Okay, that's good. Okay, so if you don't have any question, I can assume that you know everything about the how to subnet here, right? So now I come back to my lecture here. 11. Okay, so remember that so far you know how to subnet it. You know that so far you know how to subnet it. So basically, if you want to subnet it, you just borrow some bit You have network portion and hot portion. You borrow some bit, you bring it from the hot portion to the network portion here. But so far, you know that the way you breaking down the network, it is you break it down into equal subnet. Right? Every subnet has the same number of bit in the hot portion, and every subnet has the same usable address here. Right? And in the case that you're working with the equal subnet, they call it the fixed length subnet mask here. Fixed length subnet mask, because when you break it down in the subnet, every subnet has the same subnet mask. So when you have the same subnet mask, they are the fixed length here. Right? So think about at the beginning you have the /24. Now you bring it down into the /26. That means you're able to break it down. You borrow 4 bit here. That means you're able to break it down in the 16 subnet. Right? 16 subnet, and they are equal. All of them have the /28 here. So that is the fixed length subnet mask. But when working with the fixed length subnet mask, remember that you have to remember to balance between the number of the subnet requirement and the number of the address in for each subnet here. Right? You only have to balance on that one. And we already work something on this one. On this one, right? On the last Thursday, we're working on this one, and you know that basically you have to meet the two requirements here. The first one is the number of the subnet. The second one is the number of usable address in each subnet here. Remember that when you break it down, you only have to meet the two requirements here. Now you come back to the second one. It had working the variable length subnet mask here. They are not equal, right? So we think about you have original network here. So basically, if you break it down into 4 equal subnet, you just break it down equally here. You think about we have the cake, and we cut it into the 4 pieces equally here. That is the fixed length subnet mask here. But in the case of variable length subnet mask, you're able to break it down into unequal here. Right? So we think about this one. You have very large network. You use half of that. Half of that for the very large one. So for this one, again, you can break it down. You use the second one for this one. And for the third one, again, you're able to break it down for the third here, and for the fourth here, you're able to break it down furthermore here. Right? So see, think about this one. At the beginning, you have a /24. Now, you borrow 1 bit. For this one, you have /25. You borrow 1 bit, that means you're able to break it down into 2 equal, right? The first one here, and the second one here. Now, for the second one, again, you are able to break it down furthermore. So this one /26, this one /27, this one /28, and it's up to you. You can break it down furthermore. So in that case, they are not fixed here because they are not equal. In that case, they are variable length subnet mask. This one 25, this one 26, this one 27, and so on here. They are not the same. Right? Okay, so we'll see the video explain very about the variable length subnet mask basic here. See why you have to break it down into variable length here.
The basics of VLSM, or variable length subnet masks, works like this. 1. Subnets do not have to be equal sizes, as long as their address ranges do not overlap. So we can create unequal sized.
One thing about the subnet, you have to remember that each of them is a separate here, and they have no overlap here. Remember something like that. You have no way to have overlap in the subnet mask here.
Subnets. They do not all have to be the same size. 2, when creating subnets, it is easier to work from larger to smaller subnets.
And the second one, when you're working with a variable length subnet mask, remember you only have to sort it in the order from the largest one to the smallest here. And the reason you have to sort it in the order from the largest to the smallest is it will overcome the problem of overlap here. So when you sort in the order from the largest to the smallest, and when working with the subnet, it will make sure that you have no overlap in the address range here.
So for example, I have the 192.168.1.0/24 network. I subnet the network into 4 subnets /26.
This one is a fixed length subnet mask here, right? So we see when you have a /24, you borrow 2 bits, right? So when you borrow 2 bits, you have a /26. And when you borrow 2 bits, you're able to break it down into 4 equal subnet here.
Subnet masks. So the subnets go up by 64.
It's a
I
magic
now
number.
have 4 equal-sized subnets. With VLSM or variable length subnet masks, I can decide that I want to change one of these subnets and further subdivide them into smaller subnets, as long as the address spaces that I create, or the subnets that I create, do not intrude into the other subnets. For instance, I could take this 192.168.1.192 subnet. The address range for this subnet goes from 192 all the way up to 255. What I can do is I can say, instead of having this subnet /26, what if I take that address space and divide it into 2 smaller subnets, size /27 each?
So you see, for this one, you have /26. Right? You borrow 1 bit, you have a /27. When you borrow 1 bit, you're able to break it down into 2 subnets here. Right? So the magic number for the /27 is the 32. That's why the first one is a 192 and the second one is a 224 here. Right? So if you look on this one, basically, right now you're able to break it down into 5 subnets, not 4. You have 1, 2, 3, 4, and 5. And they are not on the same side, right? This one is the same. 3, this one is the same here. But this one is 27. This one 27. It's not the same. So this is the kind of variable length subnet mask here.
If I do this, I effectively have created 5 subnets. The 3 subnets up here are 64 hosts each, and the 2 new subnets that I created from the 4th subnet are 32 hosts each. The reason I can do this is because my 2 smaller subnets do not intrude into the larger subnets. This is variable length subnet masks. In this situation, it has also allowed me to create 5 subnets, thus escaping the equal-sized subnet limitation of creating subnets in powers of 2. This gives me greater flexibility and allows me to create subnets of different sizes based on the requirements of my network.
Okay, so here what's an example for this one?
In this scenario, the task is to subnet the 172.16.0.0/23 network to create the following subnets: 1 network for 200 hosts, 1 network for 100 hosts, 1 network for 50 hosts, 1 network for 25 hosts, 1 network for 10 hosts, and 4 point-to-point networks for 2 hosts each.
Okay, so let me think about this one. I have to work in this system here. Okay, so here's the requirement. Right? So we have original network here, /2023, and now we have to break it down into 1 network, 200, 100, 100, 1 network 50, 25, 10, and 4 network for each of them support for the 2 hosts here, point to point here, right? So if you look on the requirement here, what do you think? How many network you need? How many total network you need here? What do you think? How many subnet you need? What do you think? How many network you need?
9.
We need at least 6 networks.
Now you have 1, you have 2, you have 3, you have 4, and 5, and 4 here, right? 4 network also, right? So in total you need a 9 subnet here. You need the 9 subnet, and you see the largest one here is the 200 here. So now think about this one. If you have slot 23 here, slot 23 network. So what do you think? How many bits in hot in hot portion? In the whole portion here. How many bits in the whole portion? How many bits in the whole portion? If you have slot 23 at the beginning, how many bits in the whole portion you have? Now, you know that in total you have the 32 bits, right? And you break it down in the network portion and the whole portion. You already have the 23 bit here in the network portion. So how many bits in the whole portion you have? In total, you have 32. You already have the 23 here in the network portion. So how many bits in the whole portion you have?
We have 9.
Yeah, you already have 9 now. Now see for this one. If you have the you have 9 bits in the whole portion here. So how many usable address you have? How many usable address you have if you have 9 bits in the whole portion? You have the formula.
512.
Yeah, you have 2 raised to power of 9. Remember that usable address, that means you have to minus 2 here, right? Minus 1 for the network, 1 for the broadcast. So we have the 510 here. Okay. In total, you have the 510 for this one. Right? Now think about this one. You need the 9 subnet. You need the 9 subnet. And in total, we have a 510 here. So in the case, you know that in the case, if you want to working with the equal subnet here, if you want to working with the fixed length subnet part here, that means you only have to stick to the largest one here, right? You only have to stick to the largest one in order to have enough room to support for every subnet here. So if you're working with the fixed length subnet, you have to working with the largest one. That is a 200 here. So for each of them, it's a 200 equally, right? At least 200, and you have the 9 subnet here. So at least you need 1,800 usable address here. This one is not enough. 510 here is not enough. So we see for this one, you cannot working with the equal size subnet mask here. You cannot do it. That's why you have to working with the variable length subnet mask. That means you have to break it down into the unequal subnet in order to support for the 9 subnet here. That is the reason behind that. Because when working the fixed length subnet mask, some of them very you have to wasting a lot of IP address here. You see, for the network support for 200 here, but actually for this one you only need the two IP address here. So when working the fixed length subnet mask, you're wasting a lot of IP address in some case here. So in that case, in overcome to that problem, you have to working with the variable length subnet mask here. That means you break it down into unequal subnet here. And remember one thing, when working with unequal subnet or variable length subnet part here, the first thing, you only have to sort it in the order from the largest to the smallest here. So this one, you have 200 first, you have 100, you have 50, always have to sort it in the order from the largest to the smallest here. Now we come back to the video.
Before I begin to create these subnets, I need to check to see if I even have enough addresses in this address space to create all of these subnets. So by writing out the network and the subnet mask in binary, we see that we have a /23 subnet mask. Here's 23 ones in binary. The last bit is in the 2's place. If we look at this 8-bit grouping in the 3rd octet, we see that the last one is in the 2's place. That means the subnets would go up by 2. So the next subnet will be 172.16.2.0/23.
Okay, so we see for this one, magic number here is number 2, and it's the 3rd octet, right? So even if you have the next one, you will have the 172.16, go up by 2, it's a magic number here, and /23.
So the address space that we're working with goes from 172.16.0.0 all the way up to 1.255. Let's see if this is enough addresses to create all of these subnets for this specified amount of hosts. I can see that starting from a /23 subnet mask, we have 9 host bits. So effectively, there's 512 hosts. If we look at each one of these subnets that we're going to need to create, I cannot create a 200 host subnet, but I can create a subnet for 256 hosts. That number does not reflect the usable hosts, but the total number of addresses in the subnet. Similarly, I'm unable to create exactly a 100 host subnet, but I can create a 128 host subnet, a 64 subnet, a 32 subnet, a 16 subnet, and 4 host subnets will satisfy these requirements. If I add up all of these numbers, 256, 128, 64, 32, 16, and 4 subnets of 4, the total number is 512. So I'll have exactly enough host addresses to create these sized subnets and meet the requirements. Once again, these numbers here for the subnet sizes that we'll create do not reflect the usable host addresses, but the total number of addresses in the host portion of the subnet ranges, including the network address and the broadcast address. So let's get started subnetting this network using VLSM, variable length subnet masks, and working from largest subnets to smallest subnets in order to create all of the subnets required.
And again, you have to remember, you always have to sort in order. And the reason that you sort in order from the largest to smallest, you overcome the problem of overlap here.
So working from largest to smallest, the first thing I need to do is to create a network for 256 hosts to satisfy the 200 host requirement. What I can do is I can subdivide this single network of 512 hosts into 2 smaller subnets of 256 hosts each. So instead of having a 172.16.0.0 network /23, I change the subnet mask to /24.
Okay, so we see at the beginning you have a /24, you borrow 1 bit, you have a /24 here, right? So when you borrow 1 bit, you're able to break it down into 2 subnets here. And if you look on this one, it's a magic number, it's the number 1 in the third octet, right? So that's why the first one here and the second one here, you're able to break it down into 2 subnets here. And each of them able to support for the 556 address here. And that means you have a 254 usable address here. It's enough to support for 200 hosts in the network.
This creates 2 networks, 0.0 and 1.0, each subnet having 256 or 8 host bits. Notice how the subnet mask has changed from /23 to /24, and I now have 2 256 host subnets. What I can now do is keep the first of these subnets and subdivide the second one. To do this, I simply take this 172.16.1.0/24 subnet and change it from /24 to /25. So now I have the 172.16.1.0/25 subnet. This creates another subnet, 172.16.1.128. Both subnets have a magic number of 128, meaning the networks go up by 128. So I've taken this one network of 256 hosts and subdivided it into 2 networks of 128 hosts each. Now I have a subnet to meet this second requirement. Moving on from there, I'll keep the first of these subnets and then further subdivide the second one. So now we no longer have the 1.0 network in its place. We have the 1.0 subnet and the 1.128 subnet. Then I subdivide the 128 subnet into 2 smaller subnets /26 each. So now there's no longer a 128 subnet, there's 2 subnets in its place, a 128 subnet and a 192 subnet. Both of these subnets have a /26 subnet mask. If I was to write this subnet mask in the binary conversion table here, we would see that in the fourth octet, /26 means that the last one in the subnet mask is in the 64's place, and the networks go up by 64. Furthermore, with the /26 subnet mask, you only have 1, 2, 3, 4, 5, 6 host bits, and 2 to the 6th power is 64, meaning there's 64 hosts, 62 usable per subnet. I now have my 256 host subnet, I have my 128 host subnet, and my 64 host subnet. I can subdivide the second of these two subnets into two smaller subnets of 32 hosts each. To do this, I take the 192 subnet and subdivide it by changing the subnet mask from /26 to /27, creating two subnets of 32 hosts each. So now I'm no longer using the 192 subnet /26, I'm using it as a 192/27 subnet and a 224/27 subnet. From here, I still need a subnet for 10 hosts. I can take the second of these two subnets for 32 hosts and subdivide them to two 16-host subnets. To do this, we take the 224/27 subnet, change the subnet mask from /27 to /28, and now I have two smaller subnets. From here, I take the second of these two 16-host subnets. I only need one. The second one I'll use for 4 subnets of 4 hosts each. So now instead of the 240/28 subnet, I have the 240/30, the 244/30, the 248/30, and the 252/30 subnets. Looking at the subnets that have been left, we have the 172.16.0.0/24 subnet. This is good for 256 hosts. We have the 172.16.1.0/25 subnet. This is good for 128 hosts. The 172.16.1.128 subnet /26 is good for 64 hosts. And the 192/27 subnet is good for 32 hosts. The 224/28 is a 16-host subnet. And then the last 4 subnets /30 each, 240, 244, 248, and 252, are good for 4 hosts each. Once again, these sizes do not reflect the usable hosts in each subnet, but the total number of addresses in the host portion. For usable host addresses, you need to -2 from each subnet. If we examine the host addresses closely, we'll see that none of the subnets overlap. In other words, this 172.16.0 subnet goes from 0 all the way up, since it's /24, to 255. You can see that the next subnet starts at 172.16.1.0, so the two subnets do not overlap. Similarly, this second subnet goes from 0 to 127, and we can see that from host 0 to 127, the next subnet at 172.16.1.128/26, that there's no overlap. This subnet ends at 127, the next subnet begins at 128, and so on and so forth. In the end, we've created 9 subnets of different sizes: a 256, a 128, a 64, a 32, a 16, and 4 4-host subnets. This is VLSM, and it allows us to create subnets or networks specific to the needs of the network.
Okay, so we see by working on this one, you can save a lot of IP address, right? And basically, if you're working with equal subnet mask, sometimes you're wasting a lot of IP address here. Or sometimes if you have a limit on the IP address, you cannot break it down into equal here, right? So basically, when working with the variable length subnet mask here, you have something to remember. The first thing, you always have to sort it in the order here. You have to always sort it on from the largest to the smallest. So when for each of them, you have to find out that how many bits in the hot portion you're working on that one. Right? So you have to working one by one for every single the subnet mask here. Now let's see what is this one. Okay, so now think about this one. So any one of you, if you are not working, please mute your phone. Please mute the phone. Okay, so think about this one. If you look on this one, if you look on the topology here, what do you think? How many subnet you need to have? If you look on the topology here, how many subnet you need to have? Any idea? How many subnet you have? You need to have for this one.
We need to have 4.
Sorry?
We need to have 4 subnets.
No. You see, you need one for this one, right? 1, 2, 3, and 4. For each one, this one is one network console. You have 5, you have 7, and you have 8 here. Right? So for this one, if you look on topology here, basically you need the 7 subnet here. Right? You need the 7 subnet. And remember, for each of them, for this one here, you only need to 2 is over that point-to-point connection here. Right? Point-to-point connection here. You need only 2 as well here. So basically, you see, if you break it down into the fixed length subnet mask, fixed length subnet mask here, right? If you're working a fixed length subnet mask, fixed length subnet mask, you only have to working on the largest one. This one is the largest one here, right? So in order to support for the 38 hot here, you know that you have to working on the /27 subnet, because when you have /27, that means you have the 5 bit in the hot portion, and the 5 bit in hot portion you have 2 raised to power 5. It's a 32, you minus 2, it's a 30, right? So for the 30, able to support for this one, and of course this one is the largest one, so that's why it's able to support for this one, able to support for this one, this one, this one, and this one, and this one also. Right? But the thing with this one here, if you're working with the fixed length subnet mask, you break it down into multiple equal subnet, and each of the 30 here. Right? So for this one, you have the 30 address for the subnet, but for this one, you only need 2 of them. So basically, you're wasting 28 here. You have no way to use it anymore, because when you break it down, you only reserve it, you cannot use it anymore. So you see, for this waiting 28, this one waiting 28, and this one also waiting 28. So remember that in some case, you only have the limitation on the number of IP address here. So it is a really, really huge problem with the fixed length subnet mask. That's why in some case, you have to working with the variable length subnet mask here. You break it down based on the number of requirement IP address here. Right? So you see, you're working here for each of them, you're waiting the 28 bit. Yeah, so in total, you have 3 of them waiting the 84 here. Right? So in the case of variable length subnet mask, you're able to break it down into unequal here. You're able to break it down in unequal here. So you see at the beginning, if you want to break down 1, 2, 3, 4, 5, 6, 7, 8 here. And you can reserve 1 for that. You can reserve 1 for that. And you have the 4 for this one. And this one support only 2 IP address. This one only 2, and this one only 2. It's a huge waiting here. It's a huge waiting. But when working variable length subnet mask, you can use this one, you can use this one, you can use this one, and use this one for the 4 LAN here. This guy, and you go to the 5th or whatever. You can go to the 5th, and again you can break it down more, right? You can break it down more. So we see you can save a lot of IP address here. This one you can reserve it, this one you can reserve it, and this one you can reserve it. Right? Okay. Now you have to take it to give you a specific example. Let me give you some of the example here. Not this one here. Let me take something here. Let's stop sharing. I go to specific one. Okay, so let me share it again. Okay, so now let me give you the example of the how to working the variable length subnet mask here. So think about if I give you the IP address here. Think about that one. I will give you a specific IP address, and in that you have the subnet mask. You have the IP address and you have the subnet mask. So the first thing is that you have to find out what is the network address of the original network here. That's the first thing, right? The second one, you have to sort the subnet in the order from the largest to the smallest here. And for each of them, you have to find out how many bits in the hot portion for each subnet in order to support for the requirement here. Now, the next one, you have to start from the largest one, and you have to find out what is the network address, what is the network address of the next subnet, and move on. Okay. And you have to remember about the position of the magic number here. Right now, let's go to specific example here. I have the IP address here. This is not the network address, right? So I have the IP address and the subnet mask /24 here. Now I'm asking you to break it down into 4 subnet. This one, you have this one, you have this one, and this one here. Now the first thing you have to, if you look on the /22 here, if you look on the /22 here, what do you think? How many bits in the hot portion you have? If you have /22, how many bits in the hot portion you have? If you have the network with the subnet mask /22 here, how many bits in the hot portion? Come on.
10?
Yeah, 10, right? So you have the 10 bit in the hot portion. So we have the power 2 raised to power 10, you minus 2. So totally you have a 1022 usable address, right? So see, if you have a 1022 usable address, it's able to support for all of them when you add them together, right? So the first thing you have to identify, sorry, you have to clarify that if you are able to support it into the, sorry, if you are able to have enough IP address or not. And you know that in total, you have 1022 usable address. It's enough address to support all of them here, right? That's the first thing. And remember the second one here. If you have working with the second one, if you're working with a 255 host here, so in total you need you have to add 2 here, 1 for the network address and 1 for the broadcast. So totally you need for the 257 here usable address. Sorry, address here, right? So if you have 257 address here, so basically you need something about the /23 here, because 8 is enough. Right? You have the /24 is enough, because for the /24 you only have 8 bit in the hot portion. For the 8 bit in the hot portion, in total you only have the 256. But this one you need the 257. That's why you need the 9 bit here, not 8. Right? the 9 bit here. So if you know that if working with 9 bits, that means you have the slot 23. And at the beginning, you have the 23 here. When you move to the slot 23, that means you only borrow 1 bit. And remember that when you borrow 1 bit, you only able to break it down into 2 subnet. For this one, you need the 4 subnet here. Sorry, if you borrow 1 bit, you only able to break it down in 2 subnets. For this one, you need the 4 subnet here. So you know that the fixed length variable subnet mask is not work. It's not work here. Now we have to know that you have to work in the variable length subnet mask. Okay. In the case of variable length subnet mask, you have to remember that you only have to sort it in the order from the largest to the smallest here. Now, come back to my problem. That is the IP address. That is a subnet mask here. 192.168.67.56 and slash 22. The first step, you have to find out what is the network address for this one. What is the network address for this one? If you have 192.168.67.56/22 here, what is the network address? What is the network address here? Of course, you can working by the ending logic. You can working by ending logic or the subnet mask. Or the magic number here. So now think about if you working with the ending logic. You break it down every bit. You break it down every bit into the 0 and 1. So for this one, you have the 192.168.67 and 56 here. This one you have slot into 22 here, right? So you have 8 bit here, 255, you have 8 bit here, 255, that's 16 already, right? You have 17, you have 18, you have 19, you have 20, 21, 22, right? That's why we have 22 bit number 1 here, 8 bit here, 8 bit here, now 27, 28, 29, sorry, 19, 20, 21, 22, and of course every bit after that is 0 here. All right, so now this one is the IP address. User ending everything with the subnet mask. You see, you have the 192 ending with 255. You keep the same here. You keep the same here. When you ending with 255, you keep the same. That's why you have 128 here. This one you have to break it down. 67, you break it down into the 0 and 1. You have 0, 1, 0, 0, 0, 0, 1, 1, and 1 here. And for the slot 22, you have 1, 1, 1, 1, 1, 1, and 0, 0 here. And of course, everything here is 0, right? So when you ending together, you have 0 and 1, you have 0, 1 and 1, you have 1, 0 and 1, you have 0, 0 and 1, you have 0, and so on. So this is a binary here. And of course, when you convert it to the decimal, you have 64 for this one. And you have the 64 for this one here. So you have the network address here, 192.168.64.0. That is the network address. And for the broadcast address, remember in the broadcast address, you keep this one the same. You only keep the network portion the same and change every bit in the hot portion from the network address to number 1 here. You see, change it to 1. That's why you have the 67 here. That is when working the ending logic. It's up to you. You can working with the ending logic or you can working with the magic number. It's up to you. But for my magic number, it's a way easier and faster here. Now, the second one working the magic number. You know that this one is a slot 22, right? So we have the 8 bit here, 16, 17, 18, 19, 20, 21, 22. That is the magic number. So this one, you have this one 128 here, this one 64, this one 32, this one 16, this one 8, and this one 4. Yeah. So you see, this one, the magic number is the number 4. It's the number 4, and in the third octet here, in the third octet. That's why you have to focus on the third octet. So at the beginning, you have this one here, 192.168.67.56 here. All right. So now you know that you have to focus on this one. You have to focus on the third octet, and the magic number here, it is number 4. So you have to find out which is the number that close to the 67. When you divide by 4, you have no remaining. So what is it? What number is close to the 67? And when you divide when you divide by 4, you have no remaining here. What is it?
64.
Yeah, 64 here, because you see, when you take the 67, you divide by 4, you have a 16 point something, right? Remember, the network address is the one who divisible by the magic number. So you just drop it out everything here. You got the 16, you time it back to magic number here, you have 64. And it is in the third of that, right? So we know that the network address here, 192.168.64.0, it is the network address here, right? And of course, what do you think? What is the broadcast address for this one? What's the broadcast here for this one? What is the broadcast?
The 192.168.67.255.
Yeah, right. Because you have the magic number 4, so you add it up to number 4. You have the next network address. So we have 192.168.68 here. .0 is the network address of the next subnet here. So the broadcast is the one come right before this one. That's why you have 192.168 here. .67.255 is the broadcast here. And of course, the first interval will be the 192.168.64.1, and the last interval is 192.168.67.254 here. Now, the first one, you already know what is the network address of the original network here. The network address of the original one here, 192.168.64.0. The second one, you have to sort it in the order from the largest to smallest here. So you look on if you look on this one, I sort it in the order here. The first one is the largest one here. The second one, the third one, and the fourth one here. That is the third one. Now, if you think about this one, if you want to network to support for the 255 hosts, you need one more for the network address. You need one more for the broadcast. So in total, you need the 257 here. Add it to 2 here, right? Add it to 2 here. Add it to 2. Add it to 2 here. This one you have 118, 62, and the 40 here. They are not equal, right? They are not equal. Now the next one you have to identify how many bits in the whole portion you need. How many bits in the whole portion you need? This one you need the 257 address. So we have to find out how many bits here, and you can use the calculator here, right? So we think about 2 is not enough, right? 4, right? How about 3? Sorry, that's not this one. Let me do it again. So you see 2 times 2, 4 times 2, 8. It's not enough, right? So we can guess it. Of course, for me, I know that. For this one, I need to know here, because you can use the calculator here. You have 2 raised to 8. 256 not enough to support for 257 here. So I know that I need 9 here. All right. 250, 12 is enough to support for the 257 here. All right. So we see for this one, you know that this one you need the 9 bit here. This one you know that you need the 7 bit here. This one you need the 6 bit, and this one you need the 4 here. So now see, you need the 9 bit in the hot portion. So that's why you have slash 23 here, because the 23 bit is the network portion, right? And you have the 25 bit is the network portion. You have the 26 bit is the network portion, and 28 bit in the network portion here. They are not the same. That's why they call it a variable length subnet mask here. So we see again, you have the slash 23, you break it down in the binary, 8, 16, right? 17, 18, 19, 20, 21, 22, and 23 here. That's the first one. And the second one, the third one, and the fourth one here. That is in the binary. So when we convert it into the decimal, 255 here, 255 here, 254 here, and 0 here. And you do the same, 255 here, 255 here, 255 here, and 128 here. So now the next step is that for the largest one here, the network address of the largest one here, it is the network address of original one. This one, it's the same here. You take it from the original one here. Right? So you have to write down it here. You have to write down 192.168.64.0 it is a network address of the largest one. It also the network address of original one here. All right. And you see, for the largest one, the magic number here is number 2. The magic number here is number 2, and it is in the third octet. So we know that you just add it up to the magic number here, number 2 in the third octet, you have the next network address here. That's why you have 192.168.66.0 here. That's the next one, right? All right. So the broadcast address for the first one here is the one come right before this one. So that's why you have 192.168.65.255 here. And of course, the first usable address is the one come right after the broadcast. Sorry, the first usable address is the one come right after the network address. That's why you have 192.168.64.1 here. And the last usable address is the one come right before the broadcast address. That's why this one come right before here. You have 192.168.65.254 here. So now you're done with the largest one. You're done with the largest one here. Hello? Can you guys follow me? Anything's not clear, let me know. Hello?
Yeah, I'm following you so far.
Okay, everything good so far?
Yep.
Okay, that's good. All right, so now you know that you're done with the first one here, right? You're done with the largest one. Now we move to the second one. In the second one, this one, you know that is network address. This is a network address. And again, you focus on the second one, you know that the magic number for the second one here is 128. And it is the fourth octet. It's the fourth octet. That's why you have to take it from the fourth octet here. You add it up to the magic number. You know that what is the next network address here. So we have 192.168.66.128 here. Again, you come back to the second one. This is the network address of the third one. So the broadcast address is the one come right before that one here. Right? So that's why broadcast address here is 192.168.66.127 here. Again, you only have the network address here and broadcast address here. Everyone between the network address and the broadcast address, they are usable address. And the first usable address is the one come right after this one. That's why you have 192.168.66.1 here. Come right after this one. And the last usable is the one come right before this one. That's why you have 192.168.66.126 here. So now you're done with the second one. Now we do the same. You just keep doing the same with the third one. The third one, this is a network address. This is a this is a magic number 64 in the fourth one. So add it up with the magic number, you have the network address of the fourth one here. Sorry, of the fourth one here, right? So the network address of the fourth one, so broadcast address, the one come right before that. That's why you have the 91 here. And the first usable and last usable here. So now you're done. You're done with the third. Now we move to the fourth here. The fourth, you have this one is the network address. Now, for this one, you only need the 4 subnet here, but you think about you can work on the fifth one here. So we have you have the network address here, the magic number 16, add it up, you have the next network address here. So when you have next network address, you know that the broadcast is the one come right before that one. And everyone is the first usable, come right after the network, and the last usable come right before the broadcast here. So that is the way working with the variable subnet map here. Again, if you look on the process, here, the first one, you have to find out what is the network address of the original network here. That's the first thing. The second one, you have to sort it in the order. You have to sort it on order from the largest to the smallest here. The second one, you see, the first one, the network address of original one. Network address of original one. Take it, keep it, and give it to the largest one here. Give it to the largest one. So for each of one, you have to find out how many bits in the hot portion you need. You have to find out 9 here, 7, 6, and 4. And you have the subnet mask, and you have to find out what is the magic number, and you keep the process the same here. Any question from this one, let me know. again, I have to remind you that you are expected to totally understand on this one here, because in the skill exam, I give you the same problem here. I give you the IP address, and I give you the I'm asking you that you have to break it down into variable subnet mask here, and you have to know how to working with the network address, how to working with the first usable, last usable, and broadcast here. Any question from you? Let me know. Hello? Any question from you? Let me know.
Don't think I have any at the moment.
Okay, that's good.
Nope.
Yes, that's good. So that is the way working with the variable length subnet mask here. I will share this example on the announcement, and if you want to practice it, do it by yourself. And if you want to verify it, you can send the email to me so I can verify and give you some comment here. Okay. Now let me do something about. Okay. Now you can try by yourself for this one. This one, sorry, this one I have to modify it. This one's not correct here, but for this one here, for this one you can working on this one. You can practice by yourself. I will upload it in an announcement, and if you want to practice by yourself, you can do it by yourself. And if you want to verify it, you can just send me the email, and I give you some comment here. Remember that I expect you guys to practice it here, because on the skill exam, you face the same problem here. I give you an IP address, the subnet mask, and I'm asking you to break it down into the variable subnet here. Right. Okay, so if you don't have any question, let me move on. Okay, so now we know how to work in the variable length subnet mask. Now we move to the structure design. So normally is IP network planning is very important to develop a scalable solution for the enterprise network, because you have to break it down into so think about, you have the sum of the you have a network, and you want to break it down into it depend on the department, right? So you have the IT, you have the financing, and you have the business, something like that. You have HR department, and you have to reserve as a specific range of IP address for each of the department here. So it is very important when working with the network addressing here. So you think about, you give you the range of IP address, and you are required to break it down into the subnet, and assign each of the range for the specific department. So we have the HR for this one, you have the employee for this one, you have faculty, and you have student for this one, something like that. Right? Okay, and normally for the network, you have the many types of the device that requires address. You have the end user. Normally for the LAN network, you have to working with automatically. You got it from the DHCP server here. You don't have to manually configure every single one, but you can work it based on automatic. You can got it from the dedicated DHCP server. Right? You can work on the server and preference. You can work on the network device, on the gateway, and so. All right. So okay. So let me see what you have for this packet tracer here. Okay, this one. Okay, so we see for this one, this is the original one, right? This one is already the network address. But when I give you, I don't give you the specific network address. You have to pick it out. For this one is the network address of the slash 24 here. Now you have to break it down. You have to break it down into 27, 25, and the 14 and 8 here, right? So if you look on this one, you have this, what is this? You have 1, you have 2, right? You have 3, you have 4 here, right? Okay. So the first question here, how many subnet are needed in the network topology? What do you think? How many? How many? How many subnet you have? You need? Any answer for that? How many subnet you need?
We need 4.
No. Again, I have to remind you again that if you look on topology, every single interface of the router is one network here. Remember that is a very, very important element. You have to understand that every interface of the router is one network, right? So if you look on this one, what do you think? How many subnet in this topology here?
Well, then we need 6.
So we have 1 here, right? You have 2, you have 3, you have 5, and you have 6 here. Right? For this one, you need 6 subnet here, not only 4. Right? You need a 6 subnet here. You have 1, you have 2, you have 3, you have 4, and sorry, 5. You need the 5 here. So 1, you have 2, you have 3, you have 4, and 5 here. So for this one, you need the 5 subnet. Right? In 5 subnet, which subnet must accumulate for the IP address required for the switch ASW1? Right? Which subnet map the number of IP address? How many is it? Okay, so now for this one, ASW1, you have the 27 hot here. So what do you think? What is the subnet map? Accommodate for the number of IP address in the ASW1, and you can save IP address here. What is it? How many bits in the hot portion you need in order to support for the network of 27 here? What do you think? How many bits in the hot portion you need in order to support for the 27 hot here? How
5.
about 4? 4 is enough or not?
No.
4 is not, right? Because you see, you have calculator here. If you only have a 4 bit in the hot portion, you have 2 raised to 4. You have the 16. You have 16, and of course, you have the -1 for the network, 1 for broadcast. So in total, you only have the 14. And 14, sorry, where? 14 is not enough for the 27 here. So for this one, you know that you need the 5 bit here. You need 5 bit in the hot portion. So when you have a 5 bit in the hot portion, that means you have a /27 here. /27. And if you have 5 bit in the hot portion, how many usable address you have? How many usable address we have? What do you think? Let me open the word here. Okay, so see, for this one, you need the 5, right? And for this one, you need the 5 bit. You need the 5 bit for this one here, right? You need the 5 bit for this one. So what do you think? If you have a 5 bit in the hot portion, how many usable address you have?
We have 30 usable addresses.
Yeah, right. Because 2 raised to power 5, you have 32, minus 1 for the network, minus 1 for the broadcast, you have 30 here. Right. Now come to the AWS2. AWS2, where's AWS2? This one, 25 here. So for the 25 hot, what do you think? How many bits in the hot portion you need?
Need 5.
Yeah, also 5, right? And also 30 here. Now, for the SW3, you need the 14 hot here. So 14 hot here, what do you think? How many bits in the hot portion you need?
Need 4.
Yeah, 4 we, right? We got 2 raised to 4, 16, minus 2, we have 14 here. And how about the 8 hot here? How many bits in the hot portion you need?
Need 4 again.
Yeah, 4 again. 3 is not enough, right? Because 2 raised to power 3 over 8, but you have to minus 2, you only have a 6 here, not enough. Okay, so that's the way working with this one. You have to find out, right? You have to find out. Now, which subnet mask support for the number of IP address required for connection between the two buildings here? What do you think? What should be the subnet mask that you can save a lot of IP address here and enough IP address to support for point-to-point connection here? This one, the point-to-point connection, actually you only need 2 usable address only. One for this one and one for this one here. So what do you think? What is the subnet mask here? Point-to-point connection. What is a subnet mask?
/30.
Yeah, right? Because the /30, that means you have 2 bits in the hot portion. When you have 2 bits in the hot portion, you have 4 address, and you minus 2, one for the network, one for broadcast. You have 2 usable address, and it's enough for the one here and one here, right? So this one. So that's the way you're working with the original network address. Use the first one, always sort it in the order from the largest to the smallest here. Use the first one, use the second one, use the third one, the fourth one, the fifth one. And actually, if you look at my example, let me see, what is it? Tutorial. Do I have tutorial here? Okay, so if you look on the example, you can work the same, right? You just sort it in the order, and you have to find out how many bits in the network portion, what is the magic number, and you add the working with the process is the same here. Right? You just do it by yourself. Now, so we done everything with IP version 4 subnet. Remember again, this one is really important module here. So I expect you guys, you have to practice more in the package tracer and in the lab here. And if anything is not clear, let me know. Don't wait until the practice exam and skill exam here. Otherwise, too late. You have to practice a lot on that one here if you want to pass this exam here. Okay. Now we done everything with the IP version 4. How to subnet it? I think now the time to move to the IP version 6 here. IP version 4. Now move to the module 12. Okay. So with IP version 6, IP version 6 in total, you have 128 bits in the address here. Okay, you have some problem with IP version 4, right? Because it's running out IP address. So think about IP version 4. Total, you have only 32-bit address, right? So you have 2 raised to 32. You have about 4 billion IP address, and nowadays not enough. Not enough to run out. That's why they come up with the idea of IP version 6. IP version 6, you have the 128-bit address space, so we have 2 raised to power 128. It's a huge range of IP address here. To overcome the problem of the running out IP address for the IP version 4. Okay, and it's a deployment of IP version 6 also includes a fix for the IP version 4 limitation, and also it has some of the other enhancement here. And with an increasing internet population, you have a limited IP version 4 address. It have a problem with the network address translation, and nowadays you have the internet of things here. Right? Now it's the time to come with the transition to the IP version 6 here. IP version 6. So IPv6 for now, the IPv4 and IPv6 they are coexistent. I think it take a long time to transit from the IPv4 to IPv6 here, right? And you have some of the migration technique. It can be divided into 3 categories in order to coexist between the IPv4 and IPv6 here. The first one is dual stack. Then dual stack, that means a device can run both of the IPv4 and IPv6 at the same time simultaneously. The second one is tunneling, and the third one is translation here. So you can think about the tunneling. You can think about if you're working on the network, right? Suppose this one everything is the IPv4. So this one you have the this one IPv6 here, and this one IPv6. Right? So if you want to communicate between two network IPv6 together, but somehow the network between them is IPv4 here. Right? See, you have IPv6 for this network, you have IPv6 for this network, but in order to communicate together, you have the network between them, and they only support for IPv4. So in that case, you have to working with the tunneling. You have working with tunneling. So you will encapsulate every packet with the IPv4 into the IPv6 here. Into IPv6 into the IPv4. So when it send it to the IPv4, it forward it to the destination. So when you go to the destination, it ship out the IPv4 information here, and you're working with the IPv6. And the third one is translation. You're working is translate from the IPv6 to IPv4 here. Now, for the IPv6 address representation, in total you have 128 bit. You have 128 bit, and they working in the hexadecimal here. Remember, they working in the hexadecimal. In the IPv4, you can work in the binary or decimal, not hexadecimal, right? So for IPv6, they are hexadecimal, and you remember that for hexadecimal digit, each of the digit they have the 16 possibility, everything from 0 come all over to the 9, and after that you have A, you have B, you have C, you have D, you have E and F here. A is 10, B 11, C 12, D 13, E 14, and F 15. So we see everything from 0 to 15. In total, you have 16 possibility for one digit, for one hexadecimal here. Right? And for one digit, you have the 16 possibilities. That's why you need the 4 bit. Right? Because you have 2 raised to 4 here. If you have 4 bit only, you have 16 here. Right? So for each of the hexadecimal digit, you need the 4 bit in order to represent one hexadecimal digit here. So we see in total you have 128 bit. You divide by 4, in total you have the 32 hexadigit here. Hexadigit. Right? And again, for the 32 hexadigit here, they break it down into 8 group. In the 8 group, and each of group you have 4 hexadigit here. You see, you have 4 hexadigit, you have 4 hexadigit, and so on. Right? So we see you have 1, 2, 3, 4, 5, 6, 7, 8, 8 a group, and each of them you have 4 hexadigit. That means in total you have 32 hexadigit here. And for each hexadigit, you need the 4 bit. So in total, you have 32 times 4, you have 128 bit here. Right? So remember, for the IPv6, they are not case sensitive. You can write whatever it is. It can be uppercase or lowercase, whatever it is. And remember that they represent on the hexadecimal here. Each hexadecimal, you need the 4 bit, and then in total you have 32 hexadecimal, and they break it down in the 4. Sorry, they break it down in the 8 group here, and they separate each other by double column here. Double column here. All right. So now you think about this one. This one is IPv6 here. Sometimes it's very hard for you to remember, and very long in the representation here, right? So you have some rule. You have two rule. You have to rule to compress. You have to rule to compress IPv6. The first one is omit the leading 0. So whatever it is, whatever you have the leading 0, you can omit it. Right? So think about this one. You can omit it here. This one you can omit it here. This one you can omit it, and this one you can omit it here. I remember only leading 0. Right? This one you cannot, right? It's not leading here. This one you cannot. This one you cannot. The first rule, you are able to omit leading 0. So for this one, you see, you can omit this one. You can omit all the leading here. You can omit all the leading here. You can omit all the leading here. This one and this one also. So we see that is original one. Now you are able to compress it into the look, it's shorter here. Right? Remember, whenever you see 0, actually it is 40 here. When you have the C0, actually you have the 40 here. Right? The second one is a double colon here. You have the double colon. It can be replaced any single and continuous string of one or more 16-bit hash digit when you consisting of all 0 here. So we see when you have a continuous 0 in the group here, you're able to replace it by the double colon here, So you think about this one, you have continuous group of 0 here. Continuous group is 0 here, right? So you're able to replace it by the double colon for this one here. Remember, you only able to do it one time only. Right? You only able to do it one time only. You cannot do it more than one. Right? So you see, for this one, you're able to replace it from the original one here. Now it look it up, it way shorter when you compare to the original one. This one omit leading 0 here, right? This one omit leading 0 here. This one omit leading 0 here, and this one replace all of them with double colon here. Okay, and this one, of course, you omit the leading 0 here. And the reason that if you look on this one here, 1, 2, 3, 4, and 5 here. So if you look on this one, like let me give you the example here. So if you have 2001, you have A, you have B, and you have 1 here. So if you look on this IPv6 address here, what do you think? How many group of continuous 0 I have for this one here? What do you think? How many continuous group of 0 I replace it double column here? What do you think? How many continuous group of 0? Now see.
4.
Yeah, right. In total, you have 8 group. In total, you have 8 group. So this one is 1 group, the second one, the third one, and the fourth one here. So in total, you have 8 group. And if you look on this, you only have you only have a 4 group here. So you understand that actually this one is a 4 group of continuous 0 here. So actually you have to write down on this one. All right. So that is the reason you only able to see. Sorry, that is the reason you are able to use this for one time only. You cannot use it for more than one, because if you use it for more than one, you have no idea how many group of 0 it is here for this one here. Right? It makes sense. You only able to do it for one time. You cannot do it for more than once, because if you use it for more than once, you have no idea how many group of 0 for this one and how many group of 0 for this one here. Right? This one can be 1 and this one can be 3, or this one can be 2 and 2 here. You have no idea. That's why in order to compress the IPv6, the first rule is omitting the leading 0. The second one, you can replace continuous group of 0 by the double colon here. But remember, only work it for one time only. It makes sense? Hello?
Yeah, that's making sense.
Yep.
Okay. And for the IPv6 address, you have the 3 categories. The first one, unicast, one-to-one here. The second one, multicast, one-to-many here. And the third one, anycast. In the IPv6, they don't have the broadcast, but actually, somehow you can think about the multicast, somehow it's working the same with the broadcast here. Okay, now, working the IPv6 private length. So again, if you remember about the IPv4, they break it down into network portion and the host portion. This one is the network portion and the host portion. For the IPv6, it works quite the same, but the name is not the same. Right? So they break it. Sorry. They break it down into prefix and the interface ID. So we can think about prefix. It's the same with the network portion. It's a network portion, and the interface ID working is the same with the whole portion here. You can think about this one. And normally, the most commonly, so normally or the most common, they use the 64-bit in the network portion, and they use the 64-bit in the interface ID here, or in the whole portion here. You have the 64-bit here in the prefix, and have 64-bit in the interface ID, and of course, you can use whatever ID. So we can use a 60 in the prefix and 68 here in the interface ID, or you can use whatever ID. Like you can use a 68 here or 60 here, providing that when you add them up together, you have 128 here. Okay, so in the case of the Unicast IP version 6 at 1-to-1, you have some of the type IP address. You have a global Unicast IP address here. That means it's global. That means you're able to. It is a unique worldwide global, and you can working on the internet. You can go anywhere on the internet. That's global Unicast. Remember, you have the global that you're able to go to the internet, and Unicast that means it's unique here. Right. The second one is the link local. Link local address, that means you have every router of the network. Each interface is one network here, right? So we think about you have a router and you have the two interface here. So the link local address, you only need the unique inside the network only. So you can see sometimes you see this one FE H0 double colon 1 and the other one FE H0 double colon 1 here. It doesn't matter because providing that this address here is unique inside the network only, and this one is unique inside this network only. Right? So for the link local address, you need to unique inside the network only. The thing about the link local, it works the same kind of the private here. It's not always the same, but it's the for that one. And you also have the unique local address. Unique local here is the same with private. Same with the private here. Private IP address here. Okay, and you're starting everything from the FC00 7 here. Okay, now you're working with the global Unicast address here. So remember that for the IP version 6, you have the two portions here. You have the prefix ID, and you have the interface ID here, interface ID. Think about this one is the same with the network portion, and the same this one is the same with the hot portion. And when working with global Unicast address for the prefix here, they break it down into the global routing prefix and the subnet ID. The subnet ID, that means you break it down into the multiple subnet. The same working with the IP version 4 here. The global routing prefix, the global routing prefix is the one it give you from the ISP here, from the internet service provider, and you cannot change it. That is the IP address the ISP gave it to you. And the subnet ID is someone you think about. You have the interface, you have the router, and you have the three interface here. So we can break it down. This one's one network, this one is the second one, and this one is the third one. And you can work with the subnet ID here. And the interface ID is everything about the whole portion here. Right? So remember, in the case of the global Unicast address here, you have the global routing prefix. It's something that you got it from ISP, and it never changed. It always keeps the same here. And the subnet ID, you're able to change it. You can use the number 1 for this guy, number 2 for this guy, and number 3 for this guy here. Okay. Okay, so we have the global routing prefix. Normally give you from the ISP. You have the subnet ID, and you have the interface ID here. Okay. Link local. I think that's not enough for today because the two information for you guys already. So I will continue with the IP version 6 on the Thursday, but I think that today it's enough for the lecture. But I strongly recommend you to working with some of the homework here, packages in the lab here. on the class. And if you need any help from me, let me know. Because again, I have to remind you that this chapter here, 11 and the 12 here, they are really, really important. I hope you totally understand the idea behind that. Otherwise, very, very challenging for you here. So try to practice, try to do it by yourself. I know that for some of the practitioners in the lab, you can look it up on the internet. Honestly, I know that you can see somewhere on the YouTube, whatever it is. But if you don't understand the idea behind that, it will be really, really challenging for you in the skill exam and the practice exam here. So try to do it by your own. If anything is not clear, let me know. If you need any help from me, let me know. Do not literally look it up on the internet, and if you don't understand it, it will be challenging for you here. Okay, so any question from you? Any question?
I don't think I have any at the moment.
Okay, so
Not now.
if you don't have any question, I strongly recommend you to working with this homework on the class now. And if you need any help from me, let me know. I will online until the 5 p.m. And if you need anything from me, you can ping me, or you can send email to me here. Okay, so I will stop recording now. And anyway, if you need any help from me, you can ping me on the chat here.